hope you enjoyed the break. I'm talking today about L-band. I've been talking about it for quite a while. Maybe some people know me already. This time I have something more to tell, because this time is not only about theory, this time is also about practice, because we have the system up and running, and you will also see some pictures, so I hope you're going to enjoy it. Before I come to technology, I quickly want to touch base on community television. Community television is part of the South African broadcast environment. We know there's three parts of licenses. There's commercial, community, and public licenses. Community television is a very important pillar. And we also know that in the post-colonial world, when not only in the world, but particularly in Africa, when countries could find themselves back again and try to find their cultures and their roots, it's very important that media are actually, propagating those things. So mainstream media, commercial media sometimes have different interests, of course. They have to buy content cheap. They want to make money. They have to fulfill a business plan. The public broadcaster sometimes also doesn't maybe have enough resources to cover everything. So we know that local content basically the best place where you can breed and create local content is in communities. That's where it's still alive. It's where the heritage is still alive. So what we are saying is community television is contributing to preserving the cultural heritage of a country. We know that the spirit is still alive in the communities, and of course the biggest motivation for producing content is if you know that this content is going to be broadcasted. So you can tell your grandmother, hey, tomorrow morning I'll be on the show, you must switch on your TV. And you know the people that you see on the screen, these people don't know you or whatever. So for you, it's very exciting to do content, and you will be able to create a lot of local content without paying a lot of money to professional actors. And another aspect that in the municipalities, community stations are quite an important part of communication. I can see that because I'm also part of a community, which is a Westbury community in Johannesburg. We already have a community radio station there, which is on air since over 2 years now. The radio station has become the center of the community. If people have issues, they come to the radio station. So lots of conflicts, lots of problems, they are solved at the community radio station. And of course, if we look at television, community television is the next level. So we've got over 200 community radio stations in South Africa, and many of them have a feeling that they would like to become community television stations. It was not maybe possible in the past because there was no spectrum available to give many people spectrum for TV. Also, producing TV was quite expensive in the past. You needed lots of very, very expensive equipment, cameras, and then you needed very skilled people that do the white balancing and all of that on those cameras. Nowadays, technology has evolved. Nowadays, we have technology that is easy to use, that is affordable. So we would be ready for community television stations all over the place that would enrich our culture. But the problem that we have is a spectrum problem. So this is why we're here today and try to solve that problem. So there is a requirement of local community broadcasting, but particularly those countries that have adopted DVB-T2, they find themselves in that situation where it's quite difficult to have that analog scenario. 1 8 megahertz piece of spectrum equals one program can be high power, then it's going to cover a big area, can be low power, and it's going to cover a small area. To how can I convert this scenario into the digital world. So here's the solution in this presentation, and yeah, so I will go ahead. Just to have a look at the spectrum. Radio spectrum, FM and AM, where does it fit into our spectrum? It's somewhere in the lower part. Then we've got television spectrum, UHF and VHF. We've got 3 bands, so they also fit somewhere in that area. Then digital radio, you see there's 2 green lines. One is the same as VHF for TV, and there's another line there, which goes a bit higher. This is the L-band. So the first line from your left is the L-band. It's slightly higher than the other broadcast bands. It's actually the highest terrestrial broadcast band that we have. And then there's other applications. We heard before, there's police, there's taxis talking to each other, there's aviation. We haven't heard about aviation, it's a very important part. I don't think we can digitize that one, because if that fails and the airplanes fell from the sky, maybe there is some stuff that still need to maintain analog anyway. And of course there's spectrum for mobile phones. The broadcast bands are band 1, 47 to 68 megahertz. I made the suggestion that that could be used in the Northern Cape for DTT. Then there's band 3, the 8 megahertz spectrum that is used for television. There is an upper part of the band 3 which goes up to 254 megahertz up to 240 megahertz in the spectrum plan, and it is divided into 1.7 megahertz spaces instead of 8 megahertz, and it was originally intended to be used for digital radio. Then we've got the UHF band, and then in the end we've got the L band. Okay, so how has L band been used before? Here is a spectrum allocation plan, an example from Germany. So it's not a new thing. It has been used. It was used for digital radio. Not necessarily very successful, but that has more to do with the fact that generally digital radio hasn't kicked off so much in Europe yet. Only in the UK there were some successful implementations, but elsewhere digital radio is still struggling. Regulation in South Africa, we can see in that gazette here that the spectrum, and talking about this one here, 1452 to 1492, that's the spectrum that we're talking about. It is a broadcasting band. So it says a typical application is digital radio. It doesn't say it must be digital radio, it says broadcasting. Radio is an application that was intended at the time when it was developed, but it can be anything else than radio. So if we look at efficiency of computers, and Paris was talking about that before. The first time that we ever had something digital, that was the audio CD, but it was in 1982. 1982 was the first time that you really had a digital media. At that time there was no video, because video was too much information, you couldn't digitize it efficiently. At that time we didn't have compression, so it was uncompressed on the DVD, and we needed a data rate of 1.4 megabits per second to just get audio from that DVD, from that CD. So the CD, the data rate is of course from that laser that goes into the processor, into the CD player, and then you've got something that will create an analog audio signal. Now this speed, 1.4 megabits, was 1,000 times more than the highest data rate that could be used on any communication. At that time we just had 1.2 kilobits per second, which could be used for modems for data communication. Now we had this big gap, so we couldn't transport this digital signal. It could only be on a medium that we could buy in the shop and put it in our CD player. Now compression became more efficient, and then also the transport mechanism became also more efficient, so this ratio of 1,000 became smaller and smaller. So that at the first time in 1995 we had digital audio broadcasting. It was developed much earlier. They started in 1981. But yeah, the standard was ready in 1988, and 1995 it became a regular broadcast medium that was more or less the same efficiency as FM, so it was a break even. It was not much more efficient, but it was a beginning. It was the beginning of digital broadcasting, it was DAB. Then it was followed by video, so then came DVB-T, and then came DVB-H or TDMB, and in the end we have DVB-T2 in 2008. Moore's law is a very interesting law because it's very linear. You can see that with the time, in years, there is a constant increase of anything that has to do with computers. So microprocessors, the number of transistors that can be in a processor, the speed, the memory, everything grows in a very, very linear way. So we know that if you go into time, everything becomes more efficient. So what does that mean for broadcasting? Our 8 megahertz channel that we have for TV, where we could put only one analog channel in there. It could, in the beginning, when DVB-T was launched first in 2005, 2006, you could fit 4 to 5 SD channels in there. Then we had a second version of that DVB-T. It was still DVB-T, but we used a higher compression, a better compression, MPEG-4. So then we could already fit 8 to 10 SD programs into it. And that was the version of DVB-T that was initially planned to be launched in South Africa. Then DVB-T2 was, in the end, developed, which is now the current and latest standard that can already get up to 20 channels into that very same 8 megahertz, where you would only have one analog channel. So now we say this is great, this is efficient, this is spectrum efficiency. We can fit 20 channels into one frequency, and it's our 8 megahertz bandwidth, and it can have this big bouquet of channels. Now it's a big an advantage, but it's not only an advantage, because if you look at multiplexes that have 15 channels or more, like the SABC intended to be, hopefully one day they have that, multi-choice, or Platco now, ETV has launched a lot of channels, so for them it's a nice thing. They only need one transmitter, they can broadcast their whole bouquet on one transmitter. But if you need an individual footprint for a channel, like let's say for a community television channel, because it's maybe Rotoport TV, or it's Alex TV, or it is Senton TV, or it is, you name it, it's maybe it's not even a Durban TV or KZN TV, it's a community, a real community, the Nation TV. How can we put this thing? Because if we have to broadcast that channel, and we have only our big multiplexes, we have to feed it into that multiplex, and it will automatically share the footprint of that big multiplex. Currently in Gauteng, we have more than 10 initiatives for community television stations. We've got Metro and Tembisa, we've got Alex, we've got Kofifi TV. We have, of course, the existing ones, Soweto and Swana TV, and there's Ekoleni TV, and there's others. So it's a number of channels that send to Business TV coming up. So if all of them wanted to be on a multiplex, now on multiplex, we know we start with 2 multiplex, Max 1 and Max 2. So Max 1, 85% belongs to the SABC. So there's only 15% left for community television. That's 2 channels. Max 2 is shared between ETV and MultiChoice, so there's no space. So we cannot even host even if we wanted to, because we don't have that space at the moment. If we had another multiplex, yes, we could maybe share, but all of them would have to be, again, share the same footprint. So they also have to pay. It means I only want to eliminate a small area, but now I have to pay for a big multiplex for the whole of Gauteng. I'm Krugersdorp TV. I don't need to be in Soweto. I don't need to be in Heidelberg. I'm Krugersdorp. I want to serve my people. I want to be in my community. I don't want to pay Centec 100,000 rand a month to be in the whole of Gauteng. I can't pay that. I don't have that money. And basically, maybe I don't even have a license, because my license doesn't allow me to be there. My license only allows me to be where I am. So there's lots of problems, financial, legal, and other problems, regulatory problems, that will stop community television to work on this design of network that we have started with DTT. Also, if we have a multiplex operator, if he has to deal with lots of little community stations, he might also not even, maybe they don't have payment problems and other things. So you have to be very close to the communities if you want to work with them as a signal distributor. Otherwise, maybe they don't pay and then you have to switch them off or whatever. So there is definitely a need for separating those community stations and give them their own footprint. So how can we do that? Here again, just a picture to illustrate that. We've got the yellow area that would be the area of a big multiplex, and then we've got the small areas there that show the individual footprint requirements for a channel and for another channel. So in the analog world, it was easy to do that. You just put up an analog transmitter, small power, 10 watt, 15, 100 watt, whatever it is, how big you want to cover. You put it on top of that station, you switch it on, they can operate it by themselves. We call it self-operated. You don't even need a signal distributor, you do it by yourself. Some community radio stations are doing that. The majority is still with Centec, but like Kofifi FM, for example, they operate their own transmitter. There's legislation, regulation in South Africa that everyone is allowed to use his own transmitter for signal distribution. So with the current design, as I said, in DTT, it's not possible, and I think this is the right place to discuss it. Everybody is aware, or not everybody, but the policymaker was upset. They don't know what we have to do. CASA also, every day somebody's ringing on their door. It's like, we want to come a license. I say, we can't help you. We don't have spectrum for you. We can't put you in Max 1 because there's already Soweto and Tswana TV that is 15%. Don't have more space. Okay. Now, just what I said before. Your overview: Max 1, 85% SAPC, 15 community, Max 2, and there's no test space as well. So if you want to do any trials, you would have to, but there's no space for trials. You also know that in digital there is a trait between robustness and bitrate. Yeah, the higher the bitrate, the lower is the robustness. For South Africa, when the first time DVB-T2 was decided to be used as a broadcast standard, there were parameters taken that give you a bitrate of 33 megabits per second. We have not done any tests to check is it the right thing, or maybe we have to go for more robustness. I mean, I think when we start to switch on the network and everybody's got the set-top boxes at home, maybe we feel like people cannot receive the signal. Maybe we have to go down with the bitrate. Maybe it's only going to be 20 megabits or 24. So it's possible that those 15% for the communities will not even be able to give you even 2. Maybe it's only for 1. Maybe for 2, but not for more than 2 channels per province. So when developing the DVB-T2 standard, it was developed by the DVB consortium. They were obviously aware that this problem would come, and they have developed a bandwidth of 1.7 megahertz, which is much smaller than our 8 megahertz, that can actually fit this problem. So 1.7 megahertz is less than a quarter, so there's a little bit of space between. It's a quarter actually of 7 megahertz, because in VHF in Europe we're using 7 megahertz, not 8. So it's 4 times what you would fit in a big multiplex. So you can see here, instead of having 1 channel with the full big multiplex, you would have 4 individual channels, digital. They can be operated, each of them by a different community. It's enough to fit you 3 to 4 SD television channels in there, or 1 HD channel would also go into that type of transmitter. Okay, we have 1.7 megahertz slots in our spectrum plan. And what I've shown before, there was one in the L-band and there's one on VHF. So VHF is regulated for digital radio, but we don't know if it's really going to happen because the GEO6 plan anyway has been is under review. But definitely there is an L-band which is not used at this moment at all. It's a vacant piece of spectrum. It's 40 megahertz of spectrum from 1452 to 1492. It's a piece of spectrum that's not been used, and these channels would be immediately available for digital community television. Yeah. So, what propagation properties? We know that what Paris said before. A higher frequency means our maximum distance is smaller. So L-band does not travel 100 kilometers, but it goes 25, 30 kilometers depending on the terrain. So it's even better for communities because communities don't have to cover such a big area. If you really have to, you can build a single frequency network. So you can have more than one transmitter. They can all operate on the same frequency. That means you really can shape your footprint exactly the way that you want to have it. You don't need high towers. You can put it on top of buildings. Or you can share mobile masts with your mobile operators. So putting it up also doesn't have that high costs because you can use a lot of infrastructure that you basically that is not so expensive. Maybe even in that building where you have your studio, you can have on top your transmitter. You put a little mast of 15 meters and put your antenna up there, or maybe you just have a 2 kilometers to the next higher building where you just put a small Wi-Fi link in there and send the signal. As we have done it, I will show it because we are on air now. So we have that solution in theory, and now some people say, but that spectrum is for digital radio. And this is what happened in Europe. Europe people, they also lobby things. It's not only a thing that happens somewhere around here. There's something that happens everywhere, and there's people that try to keep that DAB thing alive with all that they can. We know that it's a 33 years old technology at the end of the day, and at the time when it went live, we were dealing with computers that had a 10 megabyte hard disk. This is something. It's even every USB stick that you buy now has 2 gigabytes. We're talking here about megabytes, 10 megabytes. That was a physical big hard drive that made a lot of noise. That was at that time. So this is how old the technology is. We're talking about digital technology here. So I'm not a friend of this historic keeping technology, and this is not spectrum efficient. So DVB-T2, we've got DVB-T2 Lite that can be used for digital radio if you wanted to, and it can be on the same transmitter as our digital community television station. So if we put up a transmitter like this can have a TV channel, or 2 TV channels, or 3. It can have a number of radio channels. It can have digital services. It can have applications that you can run on a set-top box, HbbTV, interactive. All these things you can do, but it can all be done by the community. The community they can create those applications. If it's a community, let's say Rustenburg, maybe they've got guest houses. Now people come, they can have their apps on the set-top box. People will be able to tune into those apps. They can see which is the tourist attractions that I want to go in that area. Where the parks. So all these things, it's a lot of job creation, lots of sustainable job creation also around this thing. So if we give the communities this tool, they can do it by themselves. Okay, so it will provide optimal conditions for community TV and radio. Precise SFNs, as I said, can be used to match every footprint that you need. Low cost and independent operation can empower a small media business to grow without taking those disadvantages. We can implement radio services and data services and everything what we need to do. We can use it also as a test platform. So if If we really want to test something new, we don't want to interfere with something that exists and maybe crash the whole thing. We can use it as a test platform and can see first, does it work in a working environment or not, before we take it live. That was a big discussion, by the way, in the public hearings. There was originally a 5% for testing. It was taken by multi-choice. There was 40% for multi-choice, there was 55% for ETV, and there was 5% for testing. Multi-choice took it, so there's no testing anymore. So it would be job creation in the media industry and those industries around the media industry. Imagine a community television channel in Rustenburg. You have makeup artists, you have journalists, you have suddenly a new restaurant that will open around that channel. So you create jobs all over the place. You have support towards content generation and preservation of cultural heritage, as I said in the beginning, information delivery within the municipalities and a lot of more things. Now what you even can do with this application, you can put a camera into a classroom. Now that child cannot go to school because the car is broken, because the weather, or because it's sick. It can watch its own classroom at home, because the school can put that transmitter in the school and can broadcast the classroom on DTT, on an L1 transmitter. Very simple, very easy, just put it together, and your receiver is your set-top box that you get anyway. If you do DTT, you get your set-top boxes. So it will be subsidized by government, everyone will have a set-top box. So everyone will have access to these services. It will be a home for all these this is, I should have exchanged that slide, because there's by now there's even a lot more logos that I would have to put in there. This is only around here. Citibank TV, Bar TV, I didn't mention them, but yeah, there's more and more coming. Okay, now the good news is this is not only theory. Luckily, ICASA gave us a license. They said, okay, go ahead, show us, does it work or does it not work? Does it work or does it not work? Because it was only free. I said, of course it's going to work, because I mean, it has been developed for that purpose, but yeah, sometimes you have surprises. So we built this thing. You can see the spectrum mask here on the left, very clean and nice spectrum mask of 1.7 megahertz of the transmitter output in the L band. Here we've got a screenshot of the transmitter. You can see it has 200 watts. And this transmitter you can see there in the area that we are broadcasting with. And from day one we had a fantastic signal. So I went with the screen and the set-top box to a place. First time that I stopped was 7 kilometers away from my transmitter in the garage. There was no clear line of sight even. I just put it up with a coffee tin antenna. And you see the yellow bar there, 100%, the green bar, 97%, very, very clear signal. So it worked from day one, it's still working very nicely. And yeah, so other concerns that came was what with the receivers, and then you know the industry, we're talking about set-top boxes. So it's a hard politics thing here, because everybody thinks, okay, if you interfere with the set-top boxes, you will put something in, you will get an advantage. Yeah? Because if I come and say, no, we need L1 in the set-top boxes, then I could maybe secretly sell set-top boxes, and others can't because they don't have L1. It's all nonsense. Every set-top box can be used. The only thing that we need to do is to upgrade the software that it can go into that bandwidth of 1.7 megahertz. We don't need an L1 tuner in the set-top box. We can have it, but we don't have it. So you can see here, this is a coffee tin that we're using as an area. This is a prototype, but yeah, you can use it as an L1 antenna. Otherwise, you can build them for a few rand. Down converter, set-top box, and the L1. That's all that you need. You use a standard set-top box, no special set-top box. Okay. So next steps. We need regulations for that, and we need some buy-in. Because nobody knows about it, or only few people know about it. So, but it's a solution for community television. Everybody is crying for a solution. Here's the solution. So we should really take it serious and say, okay, why are we not doing it? So Yesterday we heard a lot of white space. White space spectrum can also work in the L-band. So instead of letting the spectrum go and give it to some options, we keep it as broadband, but we allow white space to come in there. So we're not wasting it. We can extend the white space easily. I've asked the question yesterday, is not a problem to extend the white space specs so that they can also use this band. It needs to be in the set-top box profile, very important, set-top box standardization so that we know that it can pick up the 1.7 megahertz. It's software only, it's not an extra cost on the box. We continue with the trial, look at the regulation and policies, and at the end we need to publish the amended regulations. What happens if we don't do that? If we don't do that, we will have 100, 200,000 set-top boxes in the market. It will be difficult to implement it. So there is some immediate actions that would be important to attend. I come to my last slide. Many countries are replacing analog television with DVB-T2. But we were the first. South Africa was the first to say we are going DVB-T2. We were the first to roll out a complete DVB-T2 network. So what does it mean? We cannot copy and paste. We cannot say, what did the people do in Europe? They didn't do that. They haven't done that. We are doing the first. So we cannot just say, okay, we wanted to do DVB-T, now we just do DVB-T2. No, we have a new technology. We are the first to do it. So we must look at all aspects. We must make sure that we get the best out of it, that we use this thing to its full extent and don't leave half of it half the way away. Incorporating this community solution is maybe going to be the biggest achievement that we can reach with DTT, more than anything else, if you really look at it that way. And of course, if we are the first to do that, we can become we can make a business that we can export to other countries. Everybody's looking at every African country. They look at what was South Africa doing? When we delayed, when we had a discussion with ISDBT suddenly, all African countries, they stopped. They said, what is South Africa doing? Only when we said, okay, we go from T2, then others continued. Except Botswana, they had their own idea of going with ISDBT. But so we are sitting on an asset that can help our economy to grow, because we have a product now that we can export to other countries. Okay, thank you very much.